There's this universally held belief that we humans build complex systems to solve our problems. We spot an issue, we design a mechanism to fix it, and we fully expect that intervention to march us right toward a neat, desired resolution. It's a deeply ingrained, comforting thought, right? This assumption that we have total agency and control over the world around us. But here's the reality. Systems do not actually solve problems. Well, at least not permanently. Instead, they often end up actively constraining themselves. What starts out as a highly logical, necessary solution slowly morphs into a rigid boundary. And that leads us to a pretty stark, disturbing contradiction. The very architecture we build to protect ourselves ultimately becomes the primary threat to our survival. Part 1. The optimization paradox. So we act purposefully. We're intending to create local safety, yet by doing so, we trigger a cascade of secondary effects that produce unintended global fragility. The sociologist Robert K. Merton actually pointed this out in his work on unintended consequences. Whenever you intervene in a complex system, you're always going to create powerful knock-on effects. Sure, we achieve our immediate goal, but simultaneously, we trigger this chain reaction that runs completely contrary to what we originally wanted, silently weakening the entire foundation. Part 2. Rational local decisions. Let's picture a town situated right next to a river. A flood threatens the town, so they build a levee. This is a completely rational, hyperlocal decision that gives them immediate safety. But now the river moves faster because it can't spill onto its natural floodplains anymore, so it starts depositing its silt directly into the riverbed, which gradually raises the bottom of the river. Now, to maintain the exact same level of protection against this new, higher water level, the levee has to be raised. The system has responded. Now, this physical construction mirrors our organizational reality perfectly. You know, that constant pressure to minimize development time, meet those immediate goals, and just make expedient choices? That's what drives behavior. When a team builds a new piece of software, or when they design a new institutional policy, they are essentially building a levee. They're solving for the immediate threat. They optimize for the short term to deliver a quick release, and honestly, it's perfectly logical in the moment. Part 3. Accumulating structural constraints. Back at the river, the trapped water's potential energy is increasing. The levee is now towering over the town. That exact same solution that once protected the citizens now poses a catastrophic threat. Why? Because the riverbed is now higher than the town's streets. A breach wouldn't just cause a minor flood anymore. It would literally wipe the town off the map. The underlying tension has multiplied exponentially, and it was generated entirely by our ongoing attempts to just maintain safety. At this point, the resource allocation fundamentally shifts. The cost of managing that initial, natural flood risk, it's entirely eclipsed by the massive effort now required just to maintain the system today. The complete domination of incremental, expedient changes has resulted in a highly stressed structure. The sheer capital and energy needed simply to maintain the levee and ensure basic survival completely overshadows the original goal, which was just to live peacefully by a river. As these cumulative effects pile up, they result in increasingly fragile systems. And this growing fragility isn't an accident. It's not the result of bad intentions, a lack of funding, or incompetence. It's actually the inevitable culmination of highly rational choices made over a long period of time. By this stage, making a bold improvement, like, say, dismantling the levee entirely or moving the whole town, is structurally impossible. The system is just too entrenched. Before we continue, just a quick note. If you're looking for a calmer way to stay informed about the world, you might appreciate an app I built called Sift. It just highlights the most important news without the endless, anxiety-inducing headlines and sensational content. You can check it out via the link in the description. All right, let's get back to the explainer. Part 4. The loss of alternatives. So the hidden mechanics behind this predictable failure finally start to emerge. The first mechanism here is path dependence. This is the phenomenon where past events severely constrain later decisions. History matters, and it matters in a deeply disproportionate way. Small, seemingly insignificant initial differences, like deciding exactly where to place those very first stones of our levee, create positive feedback loops. These predictable amplifications heavily dictate later circumstances, which makes alternative choices practically invisible. The second mechanism at play is technical debt. This term was originally coined by Ward Cunningham to describe software development, but it's really the reality that short-term optimizations destroy future adaptability.
Early design constructs, which are usually chosen to minimize time or cost, act exactly like taking out a financial loan. You get the immediate benefit up front, but you are paying interest forever. Over time, making future changes becomes increasingly costly, and that locks organizations into degraded, fragile performance.
All of this creates a permanent tension between dynamic evolution and structural hysteresis. You see, economic and social systems don't just progress steadily towards some unique, predetermined, perfectly optimal equilibrium. Instead, the actual process of getting there is what dictates the outcome. Cyclical, expedient actions generate permanent structural paralysis. Over time, the system literally loses its memory of how to be flexible, permanently solidifying its own constraints.
Part 5. Irreversible System Lock-in.
Eventually, the system reaches an absorbing state. Only one path remains. The sunk cost of fixing the system, whether that means rewriting legacy software, completely overhauling a massive bureaucracy, or physically relocating a town away from a towering river, is perceived to be vastly higher than just maintaining the flawed, terrifying trajectory we're already on.
This singular path is what we call lock-in. It's a deterministic, nearly uninterruptible chain of events. Legacy systems, technical standards, and entire institutions persist through self-reinforcement. Think about the QWERTY keyboard layout or the standard width of railway tracks. Once a foundation is set and built upon, it violently resists change. It perfectly mirrors the sheer irreversibility of our towering levee. As economists Leibowitz and Margolis observed in their strong form of path dependence, we reach a state that is highly inefficient, but we are entirely unable to correct it. This historical hangover ensures that even when a chosen path is objectively disastrous, and even when all the actors within the system are fully aware of the impending danger, they are structurally prevented from changing course. So when the levee finally breaks, or the software permanently crashes, or the institution collapses, our first instinct is to look for human error. We always ask what went wrong, but the outcome was never accidental. The system was never failing, it was following its structure.